Alrighty, well, welcome to Module 4, Lesson 5, Finding 100% given another percent. Sounds a little confusing, maybe, but a very interesting and very, I think, enjoyable lesson. You can really get some great tips if you watch closely and practice these kind of time-saving techniques. Okay, so we will employ a variety of methods or techniques, including finding 1% equations. Finding 1% equations. Okay, so when you find 1%, then you can extrapolate to 100%. Mental math using factors of 100. Lots of fun. That's towards the end of the lesson. Mental math. I know many of you love to do mental math already, and this method very, very handy, and I know some of you will really enjoy it. And finally, double number lines models, which we've been using already. So just another extension, another use of those. Okay, so let's get started here. Here's our opening exercise. Okay, so what are the whole number factors of 100? That's what we're trying to find out. Okay, and what are the multiples of those factors? Okay, and therefore how many multiples are there of each factor up to 100? Okay, so you can see what they've done. They've done some for you here. You already have the factors of 100 are, of course, 100. And I mean the multiples of 100. Let me start over again. This column right here, this is going to be the factors of 100, okay, going down. Okay, you can see they have 150 done for you already, and 1 as well, okay. And now this over here, this huge column is going to be the multiples of those factors. So for example, here's the factor 100, and the only multiple of 100 is 100. Okay, all right. So that's what we have, because you can 100 times 1, because we're trying to keep it into 100. Okay, now 100, of course, there are many multiples, but we're only going up to 100. Okay, very important. All right. Okay, so why don't you go ahead, if you feel like it, go ahead and fill in this table. All right, and come on back, and we'll fill it in together. It takes a little time, but I think it's good for you to go ahead and try it on your own, okay? And be very helpful. Good to look at. Okay, yeah, so welcome back. Let's see what you've done. And the big question we're going to ask ourselves is, how can we use these factors to help us calculate percents, okay? And they're going to come in extremely handy, all right? Extremely handy. Okay, so the way I like to do it is I just went ahead and wrote in all the factors of 100, and the way I like to write factors in is to start, like, to go 100 and then 1, 100 times 1, 50 times 2, I like doing it this way, 25 times 4, 20 times 5, and then 10 times 10. Now, 10, you can't put two 10s there because they're both the same number. So these are distinct factors. Okay, they're distinct factors. Okay, so there we go. Hopefully you had that. There are the factors. How many factors are there of 100? What do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factors of 100, of course. Now, if we go ahead and write the multiples of those factors, again, up to 100, that's all we are concerned with, okay, all we are concerned with. You can see 25 has 4 different factors, okay, of 100, up to 100. 20 will have 2, 4, 5. 10 is going to have 10, okay, 5, and of course I'm putting a little dot here because that just keeps going. I can't fit all this stuff in here, right, too big. And you can see here are all the factors of 4 up to, or multiples of 4 up to 100, multiples of 2, of course, up to 100, okay. Can't fit all those in. You can see they had 1 already with the little ellipse, little dot. like I use to represent stuff in between. If you don't know what that means here, there's a little dot, 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 just means there's a bunch of stuff in between that we just can't fit. Okay, so we put the little dot, dot, dot. It's called an ellipse, and it helps out a lot. And if we go over here, you can see the numbers of multiples. So there are quite a few, okay, quite a few. And these are the multiples of the factors of 100 up to 100, okay? May sound confusing, but if you get to know this pretty well, it can help you a great deal in calculating percents, okay? Because this is the easy way. It doesn't always work out very easily, but you're going to find one time or another, you're going to bump into a number which is not itself a factor of 100, but can be taken apart into a factor of 100, okay? And we'll see that coming up. Okay, so here we go. Let's go ahead and on to example 1. Okay, and let's go ahead. We are going to use, again, we're not going to use that procedure that we just talked about. What we're going to look at, I guess we are actually, we always will be utilizing those factors of the multiples of the factors. But anyway, we're going to go ahead and use a modified double number line. It's going to look a little bit different. Okay, so here we go. Here's our problem. We have the 42 students who play wind instruments represent 75% of the students who are in the band. How many students are in the band? Okay, one thing to think about. The question we ask ourselves is which quantity in this problem represents the whole? Okay, the whole. Always so important. Finding the whole, deciding on the whole, identifying the whole. Okay, very, very important and not always so easy. But in this case, there's the students in the band. Okay, that is the whole. Okay, there's this number of students in this band, 75% of which play wind instruments. Okay? 42 students who play wind instruments represent 75% of the students. So that 42 students, which represents 75% of the band, okay? We're trying to figure out that bigger number, okay? All right, so here we go. I made, here's how it's modified a bit. We haven't actually looked at it this way before with a bit of a bar on the bottom, okay? The top remains a number line, okay, with our percentage. And again, the reason this makes sense is that this bottom section right here, the band students, okay, this represents a fixed number. It's what we call finite, okay? It is a fixed number, therefore you can create this, excuse me, long rectangular box here, or this bar, okay, this bar. The number line, again, we talked about percentages greater than 100, and we're going to see those quite often. So the number line is going to, has the capacity to go beyond 100%. But the way we've drawn it here, you can see I have that line for 100%, matches up to the end of that bar, of band student bar. Okay? And I just laid it out the way the problem presented it. And in this problem is actually saying, what it's saying is that 75% is equal to 42. Okay? And we're going to see this later on. I didn't write this here, but what we're actually saying right now, 75% is equal to 42. We're going to actually use that later to figure out 100%, which is what we're trying to do right now. But just to let you know, that's what this is saying. 75% is the same as 42, because 42 would reside right there. Okay? All right, so in this case, I hate to bring up GCF, or greatest common factor. It's always, I don't know, it makes kids get nervous all the time, okay? But again, we're talking about factors, and we're always looking at factors of 100, and we're always looking at the factor of 100, in this case, 175, okay? 175. What is the greatest common factor? The number, the biggest number that goes into both of those evenly, okay? And it is 25, okay? So therefore, we can go ahead and split this number line up into sections of 25%. And what's nice about that is it creates these nice even segments, okay, or equal segments. And we have 1, 2, 3, 4 equal. Of course, they don't look equal in my picture, but there are 4 equal segments here, which is nice because we have a finish point right here with the 75. So this 75% is equal to the 42. And what's nice is that if these here can be split up in equal segments, that means that the bar as well, the band student bar in this case, can also be divided into 4 equal segments, okay, just like I did there. And therefore, so this 42 students actually, right here, is actually equal to 3 of those segments, okay? Therefore, we can just go ahead and divide that 42 divided by 3, and we get 14. So we know each one of those segments, okay, each one of those equal segments is equal to 14, okay? All we have to do is split that bar up into the same size pieces, equal pieces, of course, as the number line, okay? Because what we're saying here is we are saying that, to go beyond this, we are saying, 25% is the same as 14. 50% is the same as 14 plus 14, which is 28. 75% is the same as 28 plus 14, which we already know is 42. So now 100% is the same as 14 times 4, because you have 14 in each. 14 times 4 segments, and that is 56 total students. Okay, so this 100% of the band is 56 total students, which is quite remarkable if we can use a procedure like this. And again, math is not all about just getting the right answer, but it's about making sense of it all, okay? And when you can see this number line on top and the finite bar of students below it, I mean, you can really, really tell, and this can really, really make sense to you, okay? So 56 total students in the band, okay? Ta-da! Okay. All right. Okay, go away now. Thank you. All right, here we go next. So now we have a another one. We have Bob's Tire Outlet here. Okay, and with Bob's Tire Outlet, we're going to continue to use the modified double number line in these three problems here. Okay, so let's go ahead and start with Bob's Tire Outlet. Okay. So Bob's Tire Outlet sold a record number of tires last month. One salesman sold 165 tires. Which was, and remember now we're saying one is the other, which was 60% of the tires sold in the month. Okay, so what was the record number of tires sold? And again, here we go. We have 60% of the tires sold is the same as 165. And so if that is the case, what was the record number of tires sold? And again, what do we need to do? We need to identify our whole first. Okay, our whole, our 100% is the record number of tires sold. That's the 100% in this case. Okay, here we go. I have made a double number line. Okay, the rest of the problems I use the number line over the bar, but in this case I just use that double number line. Put it together like this, okay, because truly this is, I mean, in essence, of truth, this should be a finite point right here, okay? There shouldn't be any arrow there. But anyway, can I erase that arrow? Oh, I can. Nice. Okay, I'll just do that. All right, so here we go. I've set it up the way they've presented it to us, because I have 60%, okay, equals 165, because that is the way it's set up, because we know 60% of this record tire sold was 165%. These are, in essence, the same thing, and that's why they sit and reside in the same spot on their respective number lines, okay? All right, so we look at 100 and we look at 60. We can look at and see if we have a GCF, and that greatest common factor, of course, is 20. okay? And again, you can look at this and not have to mess with the whole idea of a GCF, or greatest common factor. And you can just see that, hey, I can split this thing up into pieces of 20, okay, of 20%. Therefore, if I do that to the top percentage number line, I need to do the exact same thing to the bottom. Again, splitting that up into 1, 2, 3, 4, 5 equal pieces, okay? And there we go. And we have 3 of those pieces. We know 3 of those equal pieces is equal to 165, okay? Just like 3 equal pieces is equal to 60%. If we do this division, and we take that 165, divide it into 3, we get 55. So each one of these segments is worth 55 tires, okay? First segment right here, of course, is 55 right there. Add another 55, we have a 110. Add another 55, that's 165, of course, and that's what we knew. We knew that was 60%, okay? Another 55 gives us 220, and then finally another 55 gives us 275, and that corresponds to 100 on the number line, okay? And that's what we wanted to ask, and that's what our question was what was that record number of tires sold? What was our whole? What was 100%? And we find out that 100%, or all the tires sold in this record month, was 275. Okay, sorry, I didn't want to do that. I want to go, oopsie daisy. Oh, I see. Why does that happen to me? I don't know why. And let's go. Don't look. Don't look. Don't look. Don't look. Don't look. Let's go back. Wait a minute. Hold on. No, don't want to do that. Okay, let's go back. Which represents... What am I doing here? Where are we? Oh my gosh, where have we done? I'm so sorry. Let me pause here and let me get back to where I was. Okay, I'm back. I'm so sorry about that. Okay, so this next problem has Nick currently has 7,200 points in his fantasy baseball league, which is 20% more points than Adam. Now this might be a little bit confusing because, again, that first thing we want to figure out is our whole. Okay, I've created a couple of actually this I have the number line on top is going to be our percentage number line, and the bottom, those 2 bars, are going to be, one's going to be Adam and one's going to be Nick. Okay, and you could probably guess just by reading the problem which one is going to be Adam, which one is going to be Nick. Of course, the longer box is going to be Nick because he has 20% more than Adam. Okay, but the whole, which one is the whole? Is the whole Nick's current 7,200 points, or is it Adam's 20% less points? Well, because we are comparing here to Adam, because that's Nick's points are 20% more than Adam, okay, because then Adam is going to be he's going to represent our whole, okay, he is our whole because we are using him as a comparison, okay. Therefore, of course, the smaller box there is Adam, the larger one is Nick. We filled Nick's in. We know that that whole bar there equals 7,200. Don't know Adam's, okay? All we know is that Nick, his total, represents 120%, okay? Because it's 20% more than Adam's 100. See, so Adam's box needs to match up. The end of his box needs to match up to 100%, okay? Alrighty, so here we go. We have 20s. You can see a little natural division, a little natural segment has equal segment is very apparent here because we have 100 to 120 is 20%. Therefore, we go ahead and just split up our number line into our percent number line into 20% pieces. Okay, of which now all the way up to Nick's box there are 6 of those. And Adam's box, of course, has only 5 of those 20s, okay? And that's the one, and you can see there's Nick's, okay? And then, Nick's his 6 boxes, 6 segments are worth 1,200 each, 1,200 points in each one, okay, because we use his because his is a known quantity. His known quantity, that's 720 divided into the 6 even, divided by those 6 even segments or equal segments, equals 1,200. Okay, so now that we have that 1,200 number, okay, we can go ahead and fill in all of Adam's boxes, or we could just do some multiplication because we know there Adam has 5 equal segments. All of those segments are going to be equal to 1,200, okay, because all of this is equal. Okay, we have equal segments of percentage, and all the boxes below Adam's and Nick's are all going to contain the same number, in this case, number of points. Okay, and therefore we have 1,200 points per box. We can see, or per segment, and we can see that there are 1, 2, 3, 4, 5 equal segments. Therefore, 1,200 times 5 is 6,000. So Adam has 6,000 points. There they are. Okay. Now Kurt. Kurt has driven 276 miles on his road trip, but has 70% left to go. The question is, how many more miles does Kurt have to drive to get to his destination? Okay, so once again, finding the whole, uncovering, identifying the whole. Okay, all right, so here we go. We have our percentage number line, and then we have Kurt's miles driven box below it. Okay, now that get to his destination, so those miles to his destination is our whole, okay, because we want to know how much he has left to go. Now, we know 276 miles of it, okay, and we know that that is only equal to 30% because he has 70% left to go. So let's go ahead and fill these in, and there is our number line up top. Here is our miles, okay, and you can see this is what we know right now, okay. We know that 276 miles is equal to 30%. How do we know that? It wasn't actually stated, but what was stated is he has 70% of the trip left to go. Okay, therefore, all that unshaded in part of his bar is equal to 70%. Therefore, the shaded part has to equal 30%. Okay. Again, we have a GCF we're looking at this time, and again, the reason is 30, not so friendly itself. We can't split this up into 30s because 30 is not a factor of 10, but 10 is, and 10 is also a factor of 30. Okay, therefore, our greatest common factor of these two numbers is 10. So we can split our percentage number line into 10% pieces. Again, that might even be obvious without even having to mess with the greatest common factor. It might be very, very obvious to you. As long as you split this part up here into equal pieces, to get to the end of what we know. Okay, that's the really important part. Okay. And now we can go ahead and split up that 276, and you can see what we've done is we've split that 276 into 3 pieces because they correspond to the 3 10% pieces up in the number line above it. Okay? And if we do that, each of those has to be equal. Therefore, all we do is divide by 3. And we get 92. So each one of those segments is worth 92 miles. Okay, so each one of those segments is worth 92 miles. Now we have 7 segments left. Okay, 7 segments left. Each one of those segments is going to be worth the same 92 miles. Therefore, all we have to do is multiply 92 times 7, okay, because there are 7 there to fill in, and what we come up with is 644 miles, okay, 644 miles. Now, that is the answer to how many more miles does Kurt have to drive to get to his destination, and that would be 644 more miles, okay, because that 644 miles would fill in all of this part of the box, this part of his bar, his miles bar, okay. Now, if the question was, and the question could be, how many miles was his whole trip, what would we do? Can you figure it out? Well, of course, what we would do is we would add what we knew at the beginning, 276, plus that 644, and then we would get 920 miles, okay? Or we could have taken that 92 and multiplied it by the 10 sections, and that, of course, is 920 miles as well, okay? All right, but anyway, the answer to this question was 644 miles left for Kurt. Okay. Alrighty, so here we go. We're into this mental math section. Again, something I know at least a few of you out there just love to do. Okay. So what we're going to do here is we're going to go ahead and use our factors of 100. Okay, and we're going to use mental math only. Okay, and then you need to describe your method. Okay, and I'm not there, and I don't check these binders. Okay, so I'm not sure if you know how to describe it, but hopefully you do, and you will indeed write a little something down here. Okay, so I'm going to go ahead and just let you have at it for this A and B. Okay, I want you to go ahead, and I'm going to pause, and I want you to go ahead and try those, and then I'll come back and do all of them step by step, which is what I'll do with everything from here until the end. Okay, and I think everything until the end is mental math, right? Yes, mental math. Okay, all right. So go ahead and try A and B. Let's try A and B first, and then come on back. Okay, we're back. Here we go. Answer each part below using only mental math. All right, so if 39 is 1% of a number, what is that number? And hopefully there were some of you that found this very easy, but let's go ahead and look at it again, just thinking about it, mental math. All right, so like I had mentioned earlier, what this is saying here, this problem is saying 39 is equal to 1%. They are the same, okay? They are the same in this sense, okay? The same. 39 and 1% are the same, okay? Now, we're asking, what is that number, okay? What is that number? So saying 39 is 1% of a number. What is that number? Now, that number is our whole. It is our 100%, okay? But right now, we're only representing, we're only showing over here, we're only showing 1%, okay? And 1% is 39, okay? Okay, so that 39 is equal to only 1% of our whole, okay? So what we're going to look at is one whole. 1%, how do you get from 1% to our whole of 100%? Well, you multiply by 100, okay? And again, like any good algebraic process, what you do to one side of the equation, you do to the other, okay? And again, we're doing this in our head, all right? I'm doing it on paper here because I'm showing you my process, okay? Because I know that 1% times 100 is 100%. That's what I'm trying to get to. And therefore, I need to multiply that other side by 100 as well. And that would be 3,900, okay? So if I know that I have to go from 1% to 100%, multiplied by 100, I'm going to multiply that other side by 100 as well. Okay, so our 100% in this case, or that number, is 3,900. Okay, and here's the next. I hope you did well on that. The next is if 39% is 10% of a number, not 39%, if 39 is 10% of a number. What is that number? Again, I'm thinking in my head, okay, so 39 is equal to 10. How do I go from 10 to 100? Of course, I multiply by 10 to get to 100. Okay, so if I multiply that by 10, I'm just going to multiply that 39 by 10, and if I do, I get 390. So again, my 100% or my number in this case is 390. Okay? So maybe with these, I don't know if you're doing well, that's super. But if you're stumbling a little bit, just close your eyes as I kind of tell you how the process I'm going through. But anyway, I'm going to go ahead and pause again. Have you do C, D, and E, and just tell you that D is probably the trickiest of the three. It might require an extra step. Okay, so go ahead and try these. All right, so I'm back here, and now we have 39% is 5% of a number. What is that number? Here we go. I'm thinking again. I'm writing down. I know, or in my head. I'm writing in my head. Okay. Now close your eyes if you still have a little bit of difficulty with this. Just close your eyes. So you're thinking and you're just seeing this equation in your head. 39% equals 5. 39. Sorry, I keep saying that. 39 equals 5%. And now I know that the way I go from 5% to 100%, because I'm trying to find out what the whole number is, to 5% to 100% is I need to multiply by 20, of course, okay? And we have to rely on our knowledge of knowing the factors of 100, okay, and how to get to 100, all right? And 100 is a pretty gentle number, pretty easy number by this time in our lives, okay? And again, I'm thinking, okay, so if I had to multiply by 20, that means I have to multiply 39 by 20. Not as easy to do in your head as the others were probably, but if I do that, I know I have 780, okay, 780, right, which was, what, twice the amount of the 10%, right, which makes sense. Okay, so in this case, yes, our number or our 100% is 780, all right. Now this next one, if you did it, maybe you didn't get it finished, but it is a bit trickier. Simply because we're now talking about, well, here the problem is, if 39 is 15% of a number, what is that number? Okay, here's the issue now. 39 equals 15%. Okay, sure, I can see that in my head written that way, but the problem is 15%. What's the problem with 15%? Well, 15% isn't as nice and gentle as 5% was, or as 10% was, or as 1% was, because it itself is not a factor of 100, okay? It is not a factor of 100, okay, which makes it a little bit trickier. But it has a factor that is a factor of 100. And I know this might sound a little bit confusing, but think about it. What number is a factor of 15 and 100? Well, that would be 5. Okay? And you can see 5% was, we can see we used it up top. 5% is, all right? But the issue now here is that 5% is, okay? So we got to break this up here. So we know that going from 5% to 15% to 5%, I had to divide that by 3, okay? You can see I had to divide this by 3, going from here to here, okay? And I know already that 5%, or I can figure it out, 5% to get to 100% is 20, which we've done already, okay, done already up there, okay? But we have to remember, I've got to do something to this side, because what I've actually done to this side here is I've divided by 3, or of course multiplied by 1/3, all right? So what I do to this side, again, thinking great algebra, I need to do to the other side. Therefore, I need to divide 39 by 3 as well, and that comes down to 13. So these two statements are the same. They make the exact same value. 39 equals 15% is the same as saying 13 equals 5%, okay? So we've kind of changed it. We've changed this problem from if 39% is 15% of a number to if 13 is 5% of a number, okay? We've kind of changed it a little bit, but it's exactly the same value. It's not going to affect anything at all. because just like we did in the lesson prior, we're going to multiply both sides by 20, okay? Because 20 times 5% is 100%, and then 13 times 20 is 260. And I know it's kind of messy over there, but there it is, 260, okay? Now again, that might take some getting used to, but you'll find it easier and easier as you practice. And I hope some of you had a major aha moment there, okay? Because when you get to know this really well, it gets really, really exciting. Okay, and here we go, a little bit more gentle one. Okay, of course, 39 being 25% of a number, and of course, we create an equation here, 39 equals 25%. Very, very simple one we know so well. Going from 25 to 100, of course, you need to multiply by 4. Do that on both sides, and we get 156. 156 is our number in this case. Okay? And 100%, of course, is that number. Okay, so here are our last two exercises. And these two exercises, we are going to do the same. It's just a little bit different because it's now in more of a word problem format. Okay? So go ahead and see what you can do with these two. Again, being very aware, first thing you need to do is to write out your your short equation in your head. Okay, now try not to do this on paper, but rather have you do it in your head, and then go ahead and write up your method. Okay. Okay, so we're back, and let's start with Derek here. Okay, and again, you're supposed to use the same process for these. Okay. Now, Derek had a 250 batting average. I know it's a little bit strange unless you are a baseball player, and I know we have a few baseball players in this class. Unless you're a baseball player, this whole thing might look a little strange to you, this idea of a 250 batting average. You can see the way that 250 is written. We say 250, but the truth is you can see how it's written. It's written 0.250. Which is really, you can see it's 25%, okay? Because that's 0.25, which would be 25%. So Derek had a batting average, 250 batting average at the end of the last baseball season, which means that he got a hit 25% of the time he was up to bat. So they explained it to you there. But just so maybe you'll see this in the future, and you'll know what that means. That kind of means, what it does mean is Derek, and you'll see a really good batting average. Probably good batting averages generally are like 300 and above, and that's a pretty exceptional batting average. So that means 300 batting average means that the person gets a hit 30% of the time, or pretty much about one every 3 times at bat. Okay. Anyway, let's just continue here. So if Derek had 47 hits last season, how many times did he bat? And this is really, really neat, because what we see here is that we set up our little equation, because what we're saying here is that 47 hits is the same as 25%. Okay, 25% is the same as 47, because he had this 250 batting average, which means he got a hit 25% of the time, and the hits he got were 47. Okay, so that means 47 equals 25%. And I'm thinking in my head, okay, I know that. What do I know? I know that 25% times, oopsie daisy, did that again. Oh my gosh, did that again too. All right, I got to pause. Okay, I'm back. Yes, 25% times 4 is 100. Of course, I'm thinking in my mind, so I'm trying to, this mental math might not be so easy, 47 times 4. But the way I do it is 7 times 4 is 28, and then 4 times 40 is 160, so that's 188. Okay, 188. So he was up to bat 188 times. Okay, so that 100%, the total number of at-bats times he was up to bat was 188. Okay? All right, so here's Nelson. Looks like I didn't pause very much there. So Nelson used 35% of his savings account for his class trip in May. If he used $140 from his savings account while on his class trip, how much money was in his savings account before the trip. Okay, and again, we're looking at $140 is the same as or equals 35%. And here we go again with a number that is not a factor of 100. But if you are up on your factors, and a factor we've used before, we can again use 5. Okay, we can again use 5. All right, because 35, of course, is divisible by 5. 5 is a factor of 35, as 5 is a factor of 100. And so to do that, to use 5%, we need to divide that 35 by 7. And again, like any good algebraic process, what you do to one side, you do to the other, okay? And when we go ahead and divide $140 by 7, we get $20. So, just like we did before, 140 equals 35% is the same thing as saying $20 equals 5%. It's the same exact thing. But now we can extrapolate, or we can figure out what 100% would be, okay? Before, when we had the 35, it was difficult. You can't do it with the 35 mentally because it's not a factor of 100. But mentally, we can do it with the 5 because we know it is a factor of 100. And again, with the 5%, we know what to do. We multiply by 20, and we get 100% equals 400. So what we know now is that Nelson had $400 in his savings account before the trip. Okay, before the trip. All right, so that's a lot when it gets to those places where you need to break those down into smaller factors, or factors that fit into 100. Gets a little trickier. It may seem tricky, but the more and more we use it, the easier and easier it becomes. And believe me, trust me, if you're not having fun now, you will soon. Okay, so here's our lesson summary. To find 100% of the whole, you can use a variety of methods, okay, including factors of 100, blah, 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 all of those, and double number lines. Both methods will require breaking 100 into equal-sized intervals, okay? Use the greatest common factor of 100 and the percent corresponding to the part. Sounds a little complicated, but you saw what we did when we were talking about the number lines, for example. If you're talking about 75% and 100%, we can find that GCF, the greatest common factor of those two, is 25%, okay, or 25. So we would split a number line into those 4 25% pieces. I guess right there. Okay, and that's what that means, that whole GCF idea. I don't want you to just get hung up on this greatest common factor, okay, because I think it's easy enough to look at a situation. If you lay it out in the double number line format, it's easy enough to see what makes sense, the intervals, the equal segments, what makes sense. I think it will come to you without having to get all bogged down about a greatest common factor. Okay? So anyway, I hope you have fun. Enjoy your problem set and exit ticket, and see you next lesson.